This is Kaylee Mazer and Michaela Jackson from Crete Monee, Region 4, 3AA. I certify that this recording is one take, continuous, unedited video of the oral presentation and extemporaneous questions. Students have followed all rules related to this competition. You may begin your presentation now.
So for timing purposes, my partner is going to start with number 1 and number 2, writing that out on the board while I start with 3. So starting with 3, we're given a word problem and we are to write the function in function notation. Given that the function is t and our input will be m for miles. And we are supposed to it will come out to be an ordered triple of the time it would take to bike, walk, or drive a certain amount of miles. So given that you can walk 4 miles per hour, my first output in my ordered triple would be the number of miles divided by 4. So that gives you the hours it would take to walk. And then I would do the same for biking and driving. Then we're going to use the function and evaluate for t of 60 for letter B. That is a 60. So t of 60 comes out to be, you would have 60 over 4, which would give you 15. And then 60 over 12, which would give you 5, and 60 over 30, which would give you 2. And what this means is that if you were to walk 60 miles, it would take you 15 hours at the rate that we were given. And same for biking, it would take you 5 hours for 60 miles, and driving would take you 2 hours for 60 miles. Moving on to number 4. We're going to prove that it is a metric using the properties 1, 2, and 3. So starting with the first property, which is that the metric is greater than or equal to 0 for all values of x and y. And given that the functions are both constants and they are both 0 or 1, and 0, as we know, is greater than or equal to 0, and 1 is also greater than or equal to 0, since it is greater than. So that proves that the first part is true, since no matter what x or y value, they're greater than or equal to 0. Moving on to part 2, saying that the metric equals 0 when x equals y, and again, for the second piece, this does not apply since x does not equal y. So for the first piece of the function, when x equals y, it is true because for any x or y value, you will always end up with 0. And for the third part of proving it, if we were to switch x and y, since they are both constants no matter what we switch them to, you will always end up with 0 or 1, which would be the same as if it is 0 when x equals y, it is also 0 when y equals x. And it is 1 for when x is not equal to y. Well, when x is equal to y, it is 1, and when y is equal to x, it is also 1. Going back to number 1, for part A, we're using scalar multiplication. And that is so for that first one, you would distribute that 2 into all of the x values of that first order triple. And then you would distribute that 3 into all of the y values for that other order triple. And then once you have those, you would just subtract that first value minus that first value in that second order triple, and same for all the rest. But you end up with the order triple of 8, -12, -14. Then for part B, we're going to use dot product. So that is when you take the first value of x and you multiply it by the first value of y, and you do the same for each one. So we have 1 times -2, 3 times 4, 5 times -8, which comes out to -2 plus 12 plus -40, which comes out to -30. Then moving on to number 2. For part A, we are going to evaluate the Euclidean norm of 2, 3, and -4, which you just get the square root of the square root of the absolute value of 2 squared plus 3, the absolute value of 3 squared plus the absolute value of -4 squared, which would come out to the square root of 4 plus 9 plus 16, which gives you the square root of 29. Moving on to B, we have a norm on r cubed of 2 and 4. And so for that one, you would just take the cube root of the absolute value of 2 cubed plus the absolute value of 4 cubed, which comes out to the cube root of 8 plus 64, which comes out to the cube root of 72. Moving on to the last one, letter C, we have a max metric. For this one, you are going to solve for the distance between each value. So for 1 and 2, the distance is 1. For 3 and 3, distance is 0. And then you find the max distance, which we found was 6. We have finished our presentation.
I'm gonna zoom in so that they can see the board. All right, let me find my direction sheet. You will now have a maximum of 3 minutes total to solve and present your solutions to these problems. I'm gonna start a new timer. And I'm gonna give you the questions and then I'll start the timer.
Are we to begin?
Yep, you may begin.
For the extemporaneous, my partner will start on number 1 as I start on number 2. So for number 2, we're given a graph. We're given a circle and a square inside of a circle, and the outside of the square, but inside the circle, it is shaded. So we're going to start the first one. For our circle, I'm going to use a metric on the dimensions, all real dimensions. So for our circle, I have the metric of x and y, since it is centered, since our origin is 0, 0, and then our radius is 7. And then I have a max metric centered at 1, 3, and that one is greater than or equal to 2. So that shows that it's shaded outside of the square but inside of the circle. And then since there's no equal sign, we show that it is a dotted line. Moving on to number 1, for the limit, as r goes, 1 input goes to 3 outputs. We're given the function, and we are to evaluate the limit as x goes to -2. which comes out your first term to be negative 2 squared, and then your second term to be 2 times negative 2 plus 3 divided by 3 times negative 2 minus 2. And then your
15
third
seconds
term
remaining.
comes out to, is that negative 7? 2? Negative 2 plus 5.
All right, time is up. Stop. I'm gonna once again pan the board so that they can see this.